We're back for another episode of the LaunchPod, and in our Green Tech series, in partnership with Stellenbosch Municipality, we're joined by Kyle and Tom from Biotrac. Guys, great to have you on the LaunchPod.
Great to
Thanks,
be here.
Brandon.
Absolutely. I think this conversation has been long overdue. We've
Probably.
been working with you guys a couple of years now, and like wanting to unpack the story. And I think now might also be a great time to chat with you guys. Leaving a little bit of a teaser there for everyone watching. In to start it off, and I know like these can also be difficult to do, to try to take all of the knowledge of multiple PhDs and put that into 3 sentences of what you guys do. But what to kick it off, what does Biotrac do in a few sentences?
In a few sentences. Well, thought we had a half an hour for this. No, so basically, Biotrac is trying to introduce the future of microbial monitoring. Okay, kind of ushering in the way we look at microbial monitoring in terms of water systems, agriculture, etc., in a more intelligent way than we've been doing it for years. Instead of relying on antiquated lab processes and that take weeks to get results back, and having people making decision based on retroactive information, trying to give them that real time, in the moment information, and giving them that ability to make an informed decision rather than I've got 2-week-old data and let's make a call.
Yeah. And what is microbial monitoring? Like where in the normal person's life, where would we know of an instance where microbial activity happens? Like another conversation we had was with surfactants, and you have that all over the place in the day.
Yeah.
But I imagine I don't have a microbial monitor in my house. But where would I know in my world of my knowledge that someone is monitoring microbial activity, and I actually enjoy the fact, I appreciate that that's happening?
Okay. So that's I think it's a little bit harder to position to someone's household, but I think we will really kind of break it down to something I think probably more pertinent to the guys up north, with the disruption of services in terms of wastewater and that. So let's land it
like
there.
Gauteng and the water problems they have now.
Yeah. So around there where you having rivers and that having raw sewage dumped into it, and that it comes down to how do you monitor that? So in a traditional wastewater plant, and that you rely on microbial activity and a high level of it to do the work to break down waste materials or chemicals, etc.
So in a sewage treatment plant and stuff like that.
There, because if that's not being done adequately, by the time you've discharged that out of the plant, you're hoping you've done the job. The problem is what we've seen globally is becoming more of an issue is the guys wanting to do illicit dumping in the evenings. Okay. So now while everyone's sleeping, someone comes with it and dumps industrial chemicals down the waste stream. And then that collapses the microbial processes. And now by the time you've found that out, you've dump megaliters of untreated sewage into rivers or water bodies and that. And it's not a South Africa problem. Okay.
So then sewage is coming through taps in homes. If in worst case scenario that's happening.
Yeah, I think
a bit extreme.
Yeah, it's a bit extreme, but stranger things have happened up north. But that's the one side. So that's where you want the microbial activity. So where you rely on it, because that's what does the work.
Yeah.
The rest of the plant is just basically infrastructure to house them.
Yeah.
Okay.
I think that's an interesting play, because normally it's like bacteria bad.
Yeah.
But in this instance, you're like, no, we want to make sure there's plenty happening, which the everyday person doesn't necessarily realize that you want the bacteria in places. I don't know if the everyday person understands that a sewage plant, there's actually mountains of bacteria doing the work. It's not filters and machines and moving. It's like bacteria eating poop.
Yeah, well, that's the thing. That's literally it. And it's that the filtering, and that is kind of the last step. It's like a polishing step to make sure we do our best there.
That only gets if there's like a big chunk of something going out. Yeah.
So there's that side. And then on the other side is where, like you said, where traditionally we see it as a negative. We don't want bacteria in that. And that's really in terms of the food and bev kind of side of life, of where processed waters and that they use to wash bottles, wash tins, or whatever the case is. There you want a low level because again, you don't want to compromise your end product.
Yeah.
Okay. And that's the other side. So there you want to make sure that whatever processes you have in place to manage that is doing it effectively.
Yeah.
But also that you're not, like I said to you before, that you're not sitting on a traditional way of doing this, where I take a sample a day and hope that gives me a full picture of 24 hours of production cycle.
Yeah.
And to bring it home, I mean, you've got a water bottle here, Brandon.
Yeah.
When last did you wash this water bottle? Or rather, maybe...
It's an incriminating question.
Have you ever
Last week.
noticed it get dirty?
No, but it's black. The cap is black,
Yeah.
so it'll hide it.
So-
One thing I do, so I'll rinse it out, but then the cap, there's a boiling pot, and I'll pour that in the cap. So at least where my mouth goes,
Yeah.
it's sterilized.
Yeah.
At least I feel better about it.
So wherever there's water, there's going to be life. And what we do is we monitor that.
Okay.
And for instance, in a swimming pool, everyone knows that sometimes if there's a thunder shower, your swimming pool is going to go green.
Yeah.
And the problem with that is it's not at a constant interval. So sometimes it takes a week for your swimming pool to go green. Sometimes it takes 2 months, depending on the external environment. Now, if you scale that up, maybe a swimming pool is a few thousand liters. But if you are a factory or a cooling tower who's working with tens of thousands of liters per hour, you all of a sudden have a much more important problem that you have to deal with. And the rate at which things change is also a lot faster. So you need to be certain that you're on top of it and that you're not wasting money by trying to solve the problem.
Yeah. And so we're speaking very hypothetically now, but and I think there's two different things. There's one that's a lot more established and then one newer one that you guys are trying to do. Maybe, Carl, if you unpack the one that's a bit more established, how do you actually measure? And that's like we're monitoring microbial. Monitoring is like, what do you do and use and implement to measure that?
Okay. Yeah, so that's a very interesting way of that we do it is, and it's come around probably about 25 years worth of academic research. Yes, I'd be worried about the water bottle drinking out of now. And that really was focused on how do you do it in a real-time manner, in a manner that's not labor intensive, that's not kind of requiring someone to be there constantly, etc., etc. So that's kind of a lot of the way that the start of the way we do it came about. Okay, and that will become pertinent later. But what we tell people is, and it's myself and you, Tom doesn't have his watch on, but we've all got smartwatches on here now. The same way our smartwatches are monitoring our heart rate and the response to our environment in that. We do this.
58.
Oh, wow, you impressed. Okay, like you leave a lot to be desired on my side, but anyway, the same way that responds, your heart rate and that responds to changes in your environment. We try to do the same thing. So what we do is we literally monitor the respiration rates of the microbes. So the same way you breathe out CO2 and breathe in oxygen.
What do you use to do that?
Oh, that's a whole bunch of sensors that we've built in.
Yeah.
Again, what the last 10 years has allowed with the innovation in terms of sensor development and cost saving, what was impossible to do as a business as little as 8 years ago, all of a sudden now makes it a cost-effective product. Because 10 years ago, what was costing us 300,000, 400,000, 500,000 rand to do in a lab, you can now bring sub 100,000. Okay, and that has only come about from external measures where people have said, well, these are great having these big scientific systems, okay, to monitor environmental conditions, etc., etc. But that's not feasible to put into factories, into houses and that. So what we've done is we've kind of ridden that wave and said, great, our core technology there, which is monitoring CO2 and that, and CO2 sensors, have come dramatically down from costing 200,000-300,000 rand per device to now you can get CO2 sensors anywhere from 1,000 to 50,000 rand, depending on what you're trying to do.
Okay.
And that has enabled the technology actually, because now it's cost effective. Because again, if you've got a R500,000 product that you're trying to sell, well, the problem's got to be significantly more than that. So that's kind of also why, because a lot of people ask us why now.
Yeah.
That's part of the why now. The problem's always been there, and the way we've done it is for the last 20 years, but last 15 years. It's great. The problem is the actual devices we needed to do it were not cost effective.
So you put a device that measures CO2 into a sewage plant to see what's happening there with the bacteria. Is it eating the poo? Is there enough to eat the poo? And okay.
So again, you want to keep it as direct as possible.
And municipalities, so I live in Onapapagaiwe, right next to the water treatment plant, where it, like 20 years ago, it was the stigma of it smells like poo, there's sawdust over there. It doesn't anymore. But basically that plant, they take a cup of water out and test it. 5 years ago, maybe that's the way you do it now.
They still do it that way.
But what you're able to enable is you put something in the sewage and you always know what's happening.
100%. So for us, it's that, again, what we try to tell people is we tell you that there's a problem. Then what you do to remediate it is your choice. But again, giving that option of real-time insight that you don't need.
You don't know.
And you don't want someone there the whole time, because you're never going to get someone to sit at 3 o'clock in the morning in the dead of winter, sitting monitoring this kind of thing.
And even if you have someone and you're paying them, they're probably not actually paying attention.
Well, probably. The thing is, humans' attention span is only X. So to expect someone to walk around and do that. So
we're talking sewage. That's one easy one, because like I definitely want the poo gone.
Yeah.
But what other, like when you talk about wastewater, what other places does that exist?
Okay, so that's the traditional wastewater. As we see municipalities and that have mentioned. Okay. The other avenue that we've started to explore is this whole concept of decentralized wastewater. Okay. And that whole concept boils down to, and it's something that really started with the guys who were off-grid living. So the guys who were living on small holdings or were living out in the middle of nowhere.
Like hippies in the crew, you sell them a device for their house.
Something like that. But that's actually has changed significantly because...
Or everyone out in Africa Burn. I think that's coming up in the next month or two.
Yeah.
Give them a few devices out there.
Potentially something like that. But that's where traditional septic systems and that were working. Okay. But then the problem is now you've still got to deal with that waste, because you're not dealing with it, you're just storing it. Okay? So what a lot of people then started doing is, okay, let's make a smaller version of a wastewater plant, start treating it, and that we can at least discharge a semi-treated water that goes into irrigation or goes into the garden or wherever. But what people have also started seeing, and it started here, but it's also going a lot more global, is the sense of, okay, maybe we can't build a wastewater plant as quick as we can build housing. So for instance, the problem is the wastewater plant by you went through upgrades a few years ago. By the time they got through those upgrades, the capacity was probably reached already. Okay. Now the problem is, do you start the process again and you get to the same point that by the time you've done all of those big earthworks and all that kind of infrastructure, you've missed the boat again. Okay. So what a lot of municipalities that are starting to say is, if you want to build a development, show us how you're going to kind of help here and say, okay, we're going to do decentralized wastewater treatment.
Okay.
That even if that water has to be discharged into a sewer or something later on, it's already half treated. Because they know they can't build wastewater plants, traditional wastewater plants.
So instead of what we understand, the municipal wastewater, now these here locally, Velgevonden and now Stellenbosch and all those things, they need to have their own treatment plant, and that's where you could also play.
So again, that's where
interesting.
The point there is you have one of these decentralized wastewater plants. The problem is, if someone dumps paint thinners down the drain, how do you know this? Or do you find it out when you have something go horribly wrong, that you're discharging water into a pond or whatever in the estate? Now it's foaming. Now why is it foaming? And now you've got that stigma of actually it isn't problematic maybe, but just that stigma of, but I know something's not right.
Yeah.
Or maybe it is actually untreated because you've managed to collapse all of that activity because someone has inadvertently or inadvertently actually just dumped paint thinners in the system because he doesn't know any better.
And it does happen all the time.
Yeah. Like people just dump stuff.
Yep.
Yeah.
And
The toilet is a black hole.
yeah. Yeah. That's where all the spiders go.
Yeah.
Yeah.
Luckily, spiders don't
In our
affect
house.
anything.
Yeah. Interesting. Okay. And so this same technology can be used in other places. And Tom, you're also chasing not a wastewater opportunity, but a different context, and unpack that a little bit of how that same technology is now being explored in something else.
So yeah, it can be used on the wastewater and it can be used on clean water.
Yeah.
So there's a lot of applications in the clean water side. And really there are so many industries that use a lot of water. And this was shocking to me. I came into it. I didn't really know about all the different industries, but mining is a very big one. They use a lot of water. There's a lot of problems with their wastewater as well. So there's also different forms of wastewater that you get. Chemical processing waters, which might be a lot more heavy on the chemical side, and they don't have as much organic matter, which makes it very difficult to do any kind of treatment on.
Yeah.
But you also have processed waters. So these are waters that people use to make things or to for different processes that they use in industrial facilities. So, for example, in tanning leather, which is a massive industry, they need a lot of water to wash out the leather, and they wash out a lot of chemicals with that as well.
Yeah.
But you also, if you have a lot of microbes in that system, they're going to start getting onto the leather and they're going to degrade the leather. Same is true in paper and pulp. So when you're producing paper or toilet paper or anything like that, you are producing a final product which has got a lot of water in it. Obviously, the water gets removed at some point to get the paper. But if it's wet and it drops on the paper is going to tear. It's going to stop the whole operation.
Even humidity.
Yeah.
And we are in the Cape. It's not Durban, but it's
yeah. So yeah, there's a lot of water. Also, another big industry is cooling towers.
Yeah.
So they use a lot of water, and a very, very thin layer, thinner than a human hair, can reduce the cooling efficiency inside of a cooling tower significantly. Which means, firstly, that the cooling goes down, and then also that layer of bacteria and fungi, it can corrode the pipes inside of the cooling tower.
Wow.
So that means they're going to have maintenance issues, they're going to have breakdowns, and it can also cause blockages inside of that.
Wow. Okay. And replacing a cooling tower, that's not a cheap exercise.
It's not a fun job.
No. Not just the actual material to replace it, but whatever needs a cooling tower stops.
Yes.
Months.
Yeah.
Wow. Okay. Maybe, so that's fascinating, like what you guys actually do. Maybe roll it back a little bit. And Kyle, you've been around it a little bit longer. Tom, you're newish to the team. Maybe both of you, Kyle, why did you pursue this as initially an academic career and now a commercial career? And then Tom, where did you catch on to that, and why did you also say, I want to spend some years of my life doing this thing and solving this problem, not just as an academic, but now you've created a company out of this. And what's that motivation? Why is it one of those things that you cannot not do?
Okay, so I think if we pin it back to the academic side and how this started, and that was, again, it comes down to doing things in a more intelligent way. And again, I think, and I might be stoned for this by some academics, it's great to do fundamental research, and it's great to do that, and it's needed. Okay, what we've done and got to be able to do today is because someone did the fundamental work 15, 20 years ago. Okay, so there's a time and a place for it. Okay, unfortunately, what I've experienced in the years that I was involved in academia and what I still experience talking to people that are still there is we'll solve something and then we'll find a problem.
Yeah.
Okay. And that's a great concept when you're trying to do fundamental research, you're trying to do a PhD and be philosophical in that. Okay. And that's great. And no problem with that.
Solve something. You haven't solved anything.
No.
But we learned something.
Yeah.
That we're not sure if anyone cares that we learned it.
100%. And I was fortunate enough that every one of my supervisors throughout my academic career was all very much applied scientists.
Yeah.
Okay. They all really, how do we solve a real world problem? So yes, do the fundamental bit, but how does that solve? And I always say to people is, I had a mentor, Professor Doug Rawlings, who sadly no longer with us, but he always used to sit through a defense. And if he asked you at the end, so what? You knew you were done. You knew you'd missed the boat because you hadn't actually solved anything. You hadn't proved that you've done all of this stuff, but so what? What difference does it make? What's the impact? Okay. And that always stuck with me over the years. So to bring it back to the technology, that was always the point is when I started with the technology, it was always how do we do something more than just academic work with this? Okay. And that's where a lot of our industry partners and they came on and started talking to us about how they see the technology and how they can use it here and there, whether it is guys looking at antimicrobial resistance and trying to screen for pharmaceuticals or guys who are big in the chemical industries and that. And that kind of pivoted my PhD really to look at a more applied avenue once I'd done a lot of the fundamental work that is critical for a PhD. And then it came to, well, I'm doing this anyway now. What's next? And then it was, okay, do I go out, find a real job, in inverted commas, as a lot of people will say to you? Do I stay in academia? And then it also kind of hit me that, well, stay in academia is great. You hear, you teach some people,
it's safe, it's cushy,
all of that kind of thing. You go out to industry, get a job. Okay, great. You guaranteed your salary in inverted commas. That people say to you every month, but there's no guarantees in life. But in the same breath is, what are you doing to change something?
Yeah.
Okay. So then it came to me and I kind of realized that the impact you're going to make is, well, you can take Anita and them, or Anita will always say this, you can either take a job or create a job. And I've always subscribed to the same thing. Is if you are able to, and you have the ability to, and it's going to be hard, it's going to be tough, and it's not going to be smooth sailing. But there's some people that will never be able to. Okay. Why not create a job or 2 or 10 or 50? Okay. And that to me became the kind of guiding thing of here. It's like, you have an ability to start something here that might be able to outlive you. Okay. And it might be the business goes on for another 80 years when I'm no longer here. Or maybe I get to a point and say, guys, I've done what I can here. The next people need to take this forward. But you build, and that's how you kind of move everyone, including yourself, forward. But also then the back end of this is we innovate in Africa, man. But we're very shy about this. We're very self-reserved and like we'll wait for the rest of the world to come save Africa. It's like I said to a group of students yesterday morning. I said, the richest man in the world, Elon, Peter Thiel and them. I said, Sequoia Capital's dudes. They're actually African. It just happens to be the Americans are like, forget about that bit. But I was like, guys, just ponder this.
Bigger market, bigger opportunities.
100%.
But those are our people doing it.
100%. And that's kind of was my driving force of saying, okay, let's start something. Let's A, innovate out of Africa, but B, let's create jobs. Let's create opportunities for people rather than sitting there going, it's going to be easy for me with a PhD to walk into a cushy position, get my salary and not actually change anything per se and have that. So what when I get to 65? You know, what did you actually achieve other than great, you got a salary, you got a pension.
Okay. Tom, why are you doing Biotrac?
I mean, I didn't come into it with the great philosophical musings that Carl
Yeah.
has. I kind of stumbled onto it. But I think what Carl said that makes the biggest amount of sense for me is you can take a job or you can make it. And I think that's very true for yourself too. Because you can either take a job or you can make your own job. And if you really want to grow, you have to make your own job. And it doesn't mean that in every single position there's going to be a job that you can make for yourself. But when you have the opportunity, you have to do it. And I came into the research lab, and Carl was my mentor at that stage. And he was always working very closely with industry, which I think is a very important thing. It brings back to sort of what is the point of doing the research?
Yeah.
If you're doing the research purely for a scientific purpose, it doesn't mean that it's not valuable. But when you're doing it together with industry, it means that someone's actually interested in it. And they were interested in it. And eventually we got to a stage where I had finished my studies. Carl was still busy with his degree. And he came to me and he said, "Do you think you can help here? Are you able to deliver any value?" And I said, let me try. And that's how we got to where we are today. I basically just try to make the thing work. And yeah, that's how we got here.
Yeah. Awesome. Yeah. I think it resonating like why the LaunchLab and Biotrac, why we like you guys around. And as much as my vision is the LaunchLab's vision, because I lead the thing. Like we want to be part of creating an innovation economy in Africa. And I think as you're unpacking it, it's like, yes, we do some pretty cool stuff down here, and we need to solve some of our own problems and then get the platform to show the rest of the world, like, look at how we're solving this much better than you actually are.
100%. 100%. And I think that's the biggest. I had a student ask me yesterday morning, what other than the politics in this country, what is the biggest hurdle to this, to innovation, to getting us forward in it? And I said, it's ourselves. It's that lack of belief that we can do it, we are good enough, that you need to be in the US or you need to be somewhere in Europe to achieve great things in that. And I said, that's great. I said, we've had people say to us from overseas, it's great technology. How did this happen in Africa? So that's great thought process you're having here, but it shows you how narrow-minded it is that, we just assumed that you're backwards and all of this, but there's so much innovation happening here.
Yeah. Once people actually arrive in Stellenbosch and Western Cape, they're like, whoa, this is like amazing.
Yeah.
There was another company that used to be here called Pseudonym. They were on a demo call with a customer in Dubai. They have most of their customers, they go to Spain every year. They have a massive South American following. I don't know why here in like South America, they don't speak Spanish. The guys are Dutch and Afrikaans. But he was on a demo call with a client in Dubai. And then suddenly, this was like 2018 when load shedding was.
Oh, yeah.
And suddenly the lights go out and the guys, their internet stayed up, they kept demoing, and the guy's like, what just happened? And Mark's like, now here's where we're going to like lose the deal here. And he unpacked load shedding. And Mark thought it was going to be like, okay, these guys are monkeys. They're not serious. They're like, they can't actually deliver. But it was the opposite. The guy's like, you mean you built this? And you don't know if you're going to have power in the next hour or not, and what it's going to look like tomorrow. And he was dumbfounded at how we were able to create with some of the environment. Now, we fixed load shedding, thankfully. A lot of that due to the private sector just taking over, saying, like, we doubled our solar capacity in 2 years from the previous 30 years of installing it. So someone made a lot of money in that whole thing. Back to, that was just a fun story. Back to Biotrac. So you have these devices, these sensors measuring CO2 in different areas and places. How's the uptake? Like who's using it? Where are people using it? You don't need to use customer names because some people might not want their names aired. Name dropping is great for PR for us, but you have sensitive customers.
Yeah.
But who's using it? Where is it useful? And what impact are you seeing from what you guys are doing? Like, so unpack some of the traction. Who's using it? Where? How?
Yeah. So okay. So yeah, our customers are very touchy and feel what's good about names and that. And that's just because the nature of the industries that they are in. But a lot of our work is currently focused on, like I said to you, the let's say the undesirable side, the inverted commas side. So the guys who are doing process water management. So the guys who are doing the work at the food and bev plants, the guys who are doing works at chemical plants, etc., and that. Because like Tom unpacked for you, the cooling towers and that is people don't understand how critical something is like a cooling tower, of just making sure you can keep your process in a certain temperature range. And the amount of energy and the amount of effort that goes behind making sure that those processes don't deviate. So what we found is, for instance, one of our use cases is, how do you keep those units up for as long as possible in terms of, for a fact these units are, most of the buildings, even here at LaunchLab, and that have cooling towers on their roofs, where they're open to the environment. So when dust, everything, microbes come in and they're going to colonize and they're going to create issues. So now the only way to manage that is, you can't stop processing, you can't clean the system every day, but you're going to chemically manage it. The same way as you manage your swimming pool with HCH, same concept. The problem with that is you don't want to do it the way you do it with HCH, where you read the back of the thing, it says, put a cup in and you hope for the best, and tomorrow morning, if it's not right, you throw another cup in, voila. On an industrial scale, it's just too risky and too expensive. So what our technology has allowed the guys to do is start saying, this is giving us real-time information as to what do we need to change. Do we need to put another cup of HCH in, or not put another cup of HCH in? Or do we need to say, well, maybe HCH isn't working for us here. Maybe we need to move to a Blue 52 or whatever the equivalent is. Okay. And that's giving them that insight into that black box that they didn't have.
So how many customers, how many plants, how many installations are out there? What's kind of the business maturity and traction?
Oh, no, okay. No. We're still very early days because, again, the technology is, I don't want to say revolutionary, I don't like the word, innovative. That there's nothing else on the market that they can peg it against. So everyone is like, okay, we're interested, but we don't know. So the sales cycle, the trial periods and that are just a lot longer than, oh, by the way, I'm selling the equivalent product just cheaper and better than someone else previously.
So it's a different process. It's different budgeting. Because they have a lab sampling budget, but they don't have a device budget.
100%.
So then, like, the approvals and the procedures, SOPs, protocols, all of that that's a big shift.
100%.
And how do you help them get across that barrier?
So we tell them, continue with your previous way of doing it. We never tell a customer replacing us, continue with that, because either it's a regulatory requirement or it's just that inertia of, I'm so used to doing it that, guys, just continue doing it. Because initially some people ask you, can we replace our normal way of doing it? The problem is that person who has that pain in that moment, and it's normally the guy who daily deals with the frustration or the phone call, the email, from a client saying, this is not right, okay? He's not the person who's sitting there making the final decision. And that person's sitting there going, but I've been in the industry for 40 years. We've done it like this for 40 years. Why change it now? But then saying, don't worry, but don't change it. Just add it to the arsenal of things you're monitoring. And while you're waiting for those results, you've got something telling you here and now, you've got a problem, or you need to start paying attention.
So what challenge does that bring when you need revenue? Like, you're a company, you're not cushy academic employees, and that's a real thing. But now you need sales to pay yourself. You also need sales to raise investment. And that could be one way to bridge the gap. But then in South Africa, it's really hard to get investment without having someone giving you money for value. And if it's that long of a sales cycle, like, how are you just navigating that sales cycle? How are you giving people the tools they need to make those decisions, to be able to shift? What's kind of your experience in navigating that whole thing? Because it's people do business with people.
Oh, yeah.
And there's their reality that they're navigating. It's not just a technical, we can help you do it faster and cheaper. There's the rest of their world that's extremely political, I imagine, in these big things.
Oh, yeah.
How do you help them manage that, or just come alongside them and be patient with them in that?
Yeah, Brandon, I think the big thing there is, it's what we try to do as best as we can, is understand the problem, okay? Because often the problem that the client's having, or that pain that they're having, is sometimes they're very good at telling you that, and it is that, but sometimes it's not that. And it's something behind it that's actually causing it, but they can't pinpoint it. And in kind of working with them and having them also kind of guide and say, okay, this is our frustration. Our financial year end is coming up, so therefore we can't do this. But can we start now budgeting, because we've got to put in our budget for August? Okay. And kind of working in that sense, understanding that their inertia and their ability to do anything fast is significantly slower than us. And how do you bridge that gap? That's very difficult, especially like you said, is doing, as you like to say, deep tech and hard tech and that here in Africa it's hard, because you don't have the $2-3 million pre-seed round that you get in the US to develop tech. Okay, so you've got to, again, it's an African way of thinking about things, and go, I can either roll over and play dead, or I can try innovate and try to do as much as I can, as innovatively as I can. And if you make it, you make it. If you don't, you don't. But at least you tried. And I think that's how we've managed to stretch the bits and pieces of money we've got over the time, and that to a point where now, with our first revenue now in December, kind of really saying, okay, cool. Now we can start taking it a bit forward more and start looking for more investment in that properly, because, like you said, investment gets to a point where they want revenue before they start investing further. But that's the only way you're going to do it in Africa, is leveraging what we do already so well, and that's innovate and survive, man, and thrive. The thing is, and that way you can get to a point where, oh, actually I've de-risked it quite a bit for the investor, because by the time you get to that point, you've already done so much, and you've kind of pulled as much value out as you can.
You had to hustle with nothing for months and years, and now it's like it's an absolute bargain to an investor once we've navigated so far with it. Yeah, there was we were talking about it the other day in an agri meeting. There was a company in France that was they put like neurosensors into vines to measure stress, because when you're making wine, you actually want a bit of stress, but not too much stress. You want some character in the wine. So they put these things on vines to measure the stress. And then they had a range like 10 to 20 or something is the ideal stress range. And we were sitting there in Bordeaux in their office, and I was with a viticulture doctor, PhD, and he just kind of laughed at the 20. And they're like, we were getting kind of 22 and just above 20 out of range before dawn, and it shouldn't be stress before that. And the colleague I was with, he just kind of laughed, and he's like, we're sitting at 27 average in a day in summer. And it broke the models of this guy. They're working in a reality that only exists in like Italy and France and Spain. And in the rest of the agri world, Australia is similar to us, where it's extreme. South America is extreme. So their technology only works in that little area of the world. And they brought it out here actually to test in our environment so that they could get their models right. And it would actually be a global thing. And that's our day to day. We're always operating in extremes, which makes a lot of our stuff a lot more robust when it goes anywhere else in the world.
100%. And I think that's why I tie it back to this inherent bit of self-inhibition that a lot of us as Africans have, where we are innovative. You have to push, you have to develop in it, and it's a function of, geography. We're on the southern point of Africa, but in the same breath that's exactly what you want out of it, is you want to stress test things, you want to get the innovation out of it, that when you do land up in a more mature market, in inverted commas, you've really worked out a lot of the bugs. You've worked out a lot of that kind of stuff that by the time it gets to, they're like, oh, it really worked then? It's like, yeah, dudes. And they're like, well, we've de-risked it, and all of a sudden that door swings open a lot easier. Yeah, it's very interesting.
But it's also something that we've actively focused on is a lot of our competing technologies, they have such stringent requirements for where they are able to optimally work.
Yeah.
And if the pH drifts by 1 pH unit or the temperature drifts by too much, they don't work.
Yeah.
And so what we've tried to do is make our sensor as robust as possible. So it can literally work in any environment, any temperature.
Mars.
Yeah, to the best of our capability. Now, obviously, it's a lot harder said than
Don't
done.
give Elon ideas, please.
That might be a whole different thing when we're colonizing Mars and there's Biotrac devices. Like, how else are we going to measure?
Yeah.
You never know, stranger things.
Yeah.
But I think, as to Tom's point, is that what we've also found in industry is guys will develop a solution and become prescriptive to people. They say, if you want this to work, this is what you need to do. And the problem is a lot of people don't want to be told you need to do this, 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 and this.
Yeah.
Or they can't.
Or they can't. And you want to be able to say, guys, yes, within reason, don't tell me you're not going to run it in a system that's at 400 degrees Celsius or something, but whatever your process is, we've tried to develop the tech that it handles what you need, not us saying, oh, by the way, you need to do 50 steps before you can bring our tech in, because again, either they're going to be giving them a headache, or they're going to tell you, sorry, not interested. The problem is big, but not that big.
Yeah.
Yeah.
So last question, landing it, and like, where are you guys going from now? So what's happening in like the water device world, and what does the next 12 months look like there? And if we were to talk to you in a year from now, what do you hope to kind of give feedback on? And are there new industries, Tom, that you guys are going into? I might have very recent knowledge of other places you guys are playing in that's extremely relevant to Stellenbosch. But what does the next year look like for you guys, hopefully?
Okay, so I'll handle the existing tech, and Tom could talk about the rest. It's really getting that product market fit. Okay, selling the first few units in that, it's a great concept.
Yeah.
Okay, what a lot of the people that we've been mentored by and that have said it's great. That's the first step. That's an initial step up in life. But that actual product market fit, and that figuring that bit out, because again, we've come from academia. We've applied a lot of that to the technology in it.
So selling a few devices does not mean product fit.
No, not even close.
I think that's a very important point to land on. It's like, great, you've generated revenue, but it doesn't mean you found product market fit.
No.
Yeah.
And that's to the point is I'm writing a report for one of the investors currently, and I've highlighted that. I said, great, we've got revenue, we've brought in some revenue in that, sold some units, no problem.
But don't pretend like that's the scalable thing. That's
the
millions.
thing. It's kind of, I'm not going to lie to anybody and say to you, we've made product market fit, because we haven't. Because the guys who've mentored us in that been in this for years and that have also said to us, guys, product market fit is anywhere from a few months to a few years. And in the case of, you might never get there. Okay. In our case, it's highly unlikely, because it's not like we're going to kill the product now during development or at the end of development and that. But it might be 6 months from now, we tell you, Brandon, guess what? We've made product market fit, everything's working. Might be in a year's time, we're still saying to you, we're still trying to get that, nudge it into where it fits and where it needs to fit. So I think that's our focus for the next 12 months, is really getting that product market fit, but also getting that independent validation thereof. Not saying, I'm coming to you and saying, Brandon, we've got product market fit, and the guys in industry are going, what are these folks talking about? No.
But I think it's one of those, like Simon Sinek wrote that book, The Infinite Game. Everyone knows about Start With Why, but The Infinite Game, you never have 100% product market fit, and then you're sorted. You might get 70, 75, 80. I don't think he uses the percentages.
No.
But never fit the whole thing, and then the target's always moving.
Yeah.
So 80 today is 60 tomorrow, is 50 the next week.
100%.
And you're always chasing 100% product market fit.
Yeah. And I think that's the way you got to see it. Is I think there's and it comes back to, like you said, a few sales doesn't mean product market fit, and that's because that's the problem. Is people think here's the goal, and once we get there, we've achieved everything. It's like, no, guys, that's the next milestone. That's the next. Okay, great. From here, we need to grow. We need to develop.
Yeah.
And I think that's to that point of that infinite game to realize that, I might get into this next position. And then Tom lands up taking over and saying, okay, I can run the next 100 meters here because this is not a sprint. This is a
better on the curve.
I hope so.
Maybe.
Yeah.
But yeah, also to
other industries, and what are you guys going into?
Yeah, to speak to what Carl's saying about constantly moving goalposts is, you have to be innovative. You have to continue to be innovative, because otherwise you're going to fall out of the game. And so what we've done is we've actually taken the exact same technology that's inside our water sensor, and we put it inside a sensor that can go in the soil. And it was initially just, interesting to see what happens. And we found that we actually very closely are able to monitor what's going on in the soil. And why is this important? Well, because the soil is the place where all the nutrients get converted for plants. So when you add fertilizer to the soil, the plants can't take them up directly. And so what happens is you have your microbes under the ground that convert those nutrients into plant food. So that means
I don't know how many people know that. Like, it's not, when you spray fertilizer on crops, there's not a direct plant eats fertilizer. There's an intermediary between fertilizer and plant.
So yeah, to generalize,
I'm learning right now.
There are some that can go directly, but they're not as stable.
Yeah.
They're either much more expensive, or they're like fast food for plants.
Yeah.
So the plant can take it up. It's going to grow really well.
It's going to make them fat and have cholesterol and have a heart attack.
Yeah. And then it won't be able, when it has stress or something like that, it won't be able to convert the nutrients that it really needs from the soil.
Yeah. Interesting. So you're moving into looking at agriculture as another avenue that's extremely relevant in Stellenbosch.
Yeah. And we're focusing currently on high precision agriculture, where farmers can actually make the changes that we can measure. And right now it's just very exploratory, but we do have a field trial coming up so that we can actually see what are the changes in the plant that we can see from the sensor. Because right now we can see what is changing in the soil, but we don't necessarily know how that's affecting the plant.
Yeah.
And that's what we really want at the end of the day, is to get more value out of the plant or reduce our inputs into the soil for the same amount of value.
But is the wine better? That's what we want to know.
Yeah.
Like, let's get to the real things here. Is the wine better?
Yeah.
And all the other things with agriculture. Yeah. Awesome. Well, we look forward to the next year. Traction on the sales side of the water management, and then what is happening on the agri side of Biotrac and how you guys roll that out. Yeah. And next year, I hope you brag about the revenue numbers, and not product market fit, but just that traction. And these investors are throwing money in our laps like a rap video because we're changing wastewater in agriculture. Yeah, guys, thanks for joining us on the LaunchPod.
Thanks, Brandon.
We'll see you soon.
Thanks, Brandon.
Awesome.